Today we're going to look at the 6 trig functions. We've already looked at 2 trig functions, sine and cosine, and so now we're going to define all 6 of them. So first off, let's just remember how to define sine and cosine. If we take an angle theta in standard position, well then this angle is going to intersect the unit circle at the point x comma y. And sine of theta gives us the y-coordinate of that point. Cosine of theta is the x-coordinate of that point. And now we can also define tangent of theta, which is just going to be the y-coordinate divided by the x-coordinate. And we can also look at the reciprocals of all 3 of these functions. So the reciprocal of sine is called cosecant. So cosecant of theta, well, the reciprocal of y is 1 over y. And the reciprocal of the cosine function is called secant of theta. And so we'll get 1 over x. And the reciprocal of the tangent function is called cotangent. So cotangent of theta is going to be the x-coordinate divided by the y-coordinate. Now let's look at some examples of using these definitions. So first example, let's evaluate tangent, how about 0 degrees? All right, so first let's just locate where 0 degrees, that's the positive x-axis. And by definition, tangent of 0 degrees, well, that's just going to be our y-coordinate divided by our x-coordinate. And so if I look at this point where my angle meets the unit circle, this is the point 1 comma 0. And so now if we divide the y-coordinate divided by the x-coordinate, we'll get 0 over 1, which is just 0. Let's try tangent of 90 degrees. So 90 degrees, that's at the top of my unit circle. And at the top, my point is 0 comma 1. So now if we plug into our definition, y over x, this time we're going to get 1 divided by 0. And well, 0 in the denominator, that means that this expression is undefined. Okay, let's try another one. How about cosecant of 45 degrees? Okay, so by definition, cosecant is 1 over y. It's the reciprocal of the sine function. And well, let's think about what our coordinates are. So if I draw a little picture here, 45 degrees, that's the middle angle in my first quadrant. Remember, our coordinates here are root 2 over 2, comma root 2 over 2. So now if I do 1 over the y-coordinate, what I'll get is 1 over root 2 over 2. But let's simplify this. So in order to simplify, I can leave my numerator the same. And then my denominator, well, instead of dividing by root 2 over 2, that's the same as multiplying by 2 over root 2. And what is this? This is just 2 over root 2. And let's continue simplifying by rationalizing the denominator. Or in other words, we're going to just multiply by root 2 over root 2. It's just a fancy version of 1. And when we do this, we'll multiply straight across. So in the numerator, we'll get 2 root 2. And in the denominator, well, root 2 times root 2, that's root 4, which is just 2. And if we finish simplifying, we end up with the square root of 2. Right. Let's try another example. How about secant of 60 degrees? So by definition, secant is 1 over x. It's the reciprocal of cosine. And well, let's locate our angle. So 60 degrees, that's the larger angle in the first quadrant. And so we know that our coordinates there are 1/2, because the x-coordinate is smaller. The y-coordinate is the larger one, root 3 over 2. All right, so if we plug into our definition, 1 over the x-coordinate is 1 over 1/2. Oh, and that's just 1 times 2 over 1, which is 2. Number 5, let's do, how about cotangent of 2 pi over 3. So our definition of cotangent is x over y. It's the reciprocal of tangent. And let's go ahead and draw our picture here. Where's 2 pi over 3? Oh, that's going to be that angle in the second quadrant, the one that's closer to the y-axis. Right? You can refer to your unit circle. And what is this point? Well, let's see. My x-coordinate is going to be a negative 1/2, and my y-coordinate is positive root 3 over 2. And so if we plug into our definition here, x over y is going to be negative 1/2 divided by root 3 over 2. And if we simplify, we'll end up with negative 1/2 times the reciprocal of root 3 over 2, which is 2 over root 3. And let's see, my 2's are going to reduce, and what we get is negative 1 over root 3. Which technically, to finish simplifying, I want to get that radical out of the denominator. So I'm just going to multiply by root 3 over root 3, which gives us, let's see, we still have our negative. In the numerator, we have root 3. And in the denominator, well, square root of 3 times square root of 3, that's the square root of 9, which is 3. And this would be our simplified answer. And let's try just one more example. Let's do number 6. Let's evaluate cosine squared of pi over 6. Okay, this is a little new. We haven't looked at exponents like this before. But all this means is we're going to first find cosine of pi over 6. And then whatever answer we get for that, we're just going to simply square it. Okay, so let's see. Cosine of pi over 6, first of all, pi over 6, that's my smaller angle in the first quadrant. And so my coordinates here are, what is this? The x-coordinate is the longer one, root 3 over 2. The y-coordinate is the shorter one, 1/2. Okay. And let's see, by definition, cosine of pi over 6, remember cosine gives us the x-coordinate, so that's going to be root 3 over 2. And then we're just going to square it. So let's see, to square it, that just means we're multiplying it by itself, right? So root 3 over 2 times root 3 over 2, which gives us, in the numerator, square root of 9. In the denominator, 2 times 2 is 4. And what we end up with is 3/4. And there we go.